Now back to that previous example where we didn't end up setting up the integral. We found the intersection points of the two curves, but putting that work aside, let's now set up the integral. The useful information from earlier was that the intersection points were at x equals 5 and x equals -1. Now, which y values do those correspond to? Well, y equals x minus 1 can tell us that. So when x equals 5, y equals 4. And when x equals -1, y equals -2. And that looks kind of like where the y value would be if my graph were better. This would be y equals 4, and this would be y equals -1. So when we set up our integral to find the area, and again, which area are we looking for? We're looking for this area, and we're using this dy method, which means we're viewing the top function as the line y equals x minus 1, and the bottom function as the parabola, which we should remember is x equals y squared minus 6 over 2, because we have to write x as a function of y. And then since we're at it, let's write x as a function of y over here. It'll be actually, let's do this just to be consistent with the notation we've been using. I'm going to just say that this is g of y for the parabola, and the line should be x equals f of y, which is y plus 1. And so when we set up the integral, this is what we're going to have. We're going to have the integral from y equals -1 to y equals 4. This is a dy integral. Y plus 1, which is the top function, in other words, the right function, the function on the right, minus the bottom function, which is actually the function on the left, which is y squared minus 6 over 2. Now I'm going to pause the video, or I'm going to have you pause the video, work the rest of it out yourself, and then see all the rest of the work up here. So take a few moments to study my work, compare it against your own. My final answer, when I simplify everything, ends up being 33 over 2. Hopefully that's what you got. All right, so to summarize what we've done in section 5.1, you need to sketch the graphs, and you need to find the bounds of integration by looking at the graphs. And depending on whether or not you have the graphs crossing each other, so there's a change in role between which one is the top and which one is the bottom, or which one is right versus left, you have to split up your interval of integration accordingly. And then to find the area, if it's a dx integral, meaning you're looking at things right side up, it'll be the integral of top minus bottom. If you have to look sideways for it, in other words, if it's a dy integral, you're going to take the integral of right minus left.